And as we move from Bob's talk moving forward, I'd like to welcome Daniel Sarr. Daniel is a recent transplant from the Pacific Northwest down to the desert Southwest. He currently works with the Grand Canyon Monitoring and Research Center on a large riparian monitoring project. But before that, he had a career in the Klamath network where he was the monitoring and inventory czar. So he's going to bring us some multiple perspectives in riparian ecology from these multiple contexts and geographic locations. Let's welcome Daniel Sarr.
All right, thanks, Nate. Thanks for the introduction. Thanks for inviting me to the conference, and thanks for working with me on this talk. And I didn't expect that to happen. That's Nate Huffsney. And thank you for some very enjoyable conversations about this notion of riverscapes and mindscapes. In other words, how do we think about riparian ecosystems? And as I'll try to point out here, in my experience, there's a great diversity of riparian landscapes across the West. And how do we transfer our thoughts along with those, and how do those line up? So this first slide, at least for this talk, this is my study area, the West. And you can see that it stands out right here. It gives the general flavor that there's something special about this place. And if you think of the plant geographers of the West, some of the very first ones like Seahart Merriam came out to where I now live in Flagstaff, and they were fascinated, like all of us are, with the elevational spectra you see in landscapes as you go from low elevations in the bottom of the canyon up to the top of the San Francisco peaks. But if you go at an even larger scale, you can see that there's a climatic effect and a biogeographic effect of all this topography and geology, so that we live in one of the most, definitely the most climatically complex area in North America. And we also happen to be in the lower 48 in one of the areas that has, at least away from the coast and with some exceptions, one of the lowest population densities. So we have a lot of environmental managers, or not that many environmental managers, dealing with a lot of complexity. And I guess the question I'm going to try to explore today, and this is an exploratory talk, so it's kind of moving from things that I know pretty well to things that I'm curious about. How does this complexity affect riparian landscapes and our thinking about riparian ecology? And we had a symposium that I organized about 6 or 7 years ago about riparian management in the national parks. And I was just looking at all the slides I received from people. And I kind of grabbed pictures out of those slides. And when I think just in the national park landscapes, I saw a lot of really interesting pictures. Now, I haven't been to all these places, but I think that it's suffice it to say that riparian landscapes are very diverse. And I'm going to try to explore a natural consequence of that observation, which is how do our mindscapes match with the complexity of our landscapes? And I'm going to say for today's talk that we're dealing with there's three different prisms that we bring to bear when we think about riparian ecosystems. You could classify this any way you want, but just bear with me. And I think that they're really important because, as we all know, we interact with landscapes according to the way we interpret them. And the more we manage them and the more we interact with them, the more it changes our perceptions of them. And so our thoughts become entrained in these topographies of perception and practice that I think it's sometimes good to shake up a little bit and break outside of. So one of the first things is thinking about the values of riparian areas. When I started this in the 80s, so I've got about 25 years thinking about riparian areas in the West, most of the papers I was reading had to do with fish habitat, allochthonous input, stream bank stability, riparian shading. There was a smaller body of papers about wildlife habitat, and then also there was work about rangelands and the rangeland health. But these are all different parts of the elephant, as you can think about it, that riparian areas are actually all of these things, but our professional experience and values tend to focus on a few of them. And in practice, a lot of us are environmental professionals. Think about it in terms of our day-to-day operations. If you go out and you're measuring a stream, I've worked with a lot of, in fact, supervised ecologists, aquatic ecologists who can tell you chapter and verse about the aquatic invertebrates, but they're not going to be able to tell you about the plants. And a person who knows the riparian plants is maybe not going to know that much about the riparian birds. So they're all different things that we get, and we get really a great stovepipe effect, a lot of depth within our area of discipline, but sometimes we don't get the breadth, unless we have meetings like this. So I think I had a cop to some of my experiences, and one thing I omitted in the first slide was a long list of acknowledgements. So I would say every place that's allowed me to look at a riparian ecosystem, I'm thankful for. So I'll talk about this. So this was probably my first formative experience in the late 80s. I was at Humboldt State, and I got hired to come up to the Kern Plateau in the Golden Trout Wilderness of the southern Sierra Nevada. And this was an area like a lot of the areas I saw yesterday that had been historically overgrazed, had had gully erosion, and the system was degraded. And our first goal was to try to repair habitat for the South Fork golden trout, which is an endemic species. But we also were trying to develop these ecosystems, and it was grazed the whole time as well, so it was rangelands. And the first thing we did is we tried to put in rock head cuts, and we put in structures, physical structures, and the stream cut around them. Then we got a little smarter, and we put in riparian exclosures, and we started to see responses like this. We started to see willow responses and sedge responses. And then the final thing we did was start to bring in outside researchers to look at these different mechanisms of restoration and recovery. And that's when I came across Bob's work that I've cited several times. Bob's work with Boone Kaufman and others, and I saw a lot of the other things. Sherman Swanson, I heard that name yesterday. This whole body of people who'd done work in the Intermountain West trying to study how systems get damaged and recover, and I found that fascinating. And I also ought to give homage to my supervisor, Del Hubbs at the time, who was the range conservationist for the Inyo National Forest, and he kind of allowed me to be kind of the ambassador out to the research community. We began exploring this. So I went back for my master's, and I came out, and meanwhile during this period I saw a quasi-intact riparian forest, some of the stuff that John Stella was talking about yesterday, these gallery forests of the Central Valley, which is where I grew up. And the Central Valley streams, they don't tend to have water in them. So there was one thing I observed. We had one flowing the Tule River right through my hometown. But they tend to have, cars, spare tires, refrigerators. So actually to see one that had this kind of a system, a gallery forest that has all the habitat values it has, was something that I really wanted to dedicate my career to understanding and preserving. But as way led on to way, I found myself in the Northwest. I was funded at Oregon State to study these kinds of systems. And so I was forced to go to the altar of large woody debris and learn about these great processes of debris flows and things with Fred Swanson and Bob Beshta and Gordon Grant and this whole group, Dave Hibbs, my advisor. And what I found there was that these systems, the hardwood component, the willow component was a smaller component. We had these big conifers that had a huge effect. And then a little bit later, I took a job with the National Park Service, and I was called on by Redwood National Park to help them talk about how to restore. This is kind of a humble thing to think about restoring redwood forests, trees that could be 2,000 years old and 350 feet tall. And so I started thinking about, okay, these are riparian forests as well, with these massive trees, and conifers dominate, and hardwoods are a smaller component. Now, if you go just 60 miles over from the coast in Northern California, you come into Southern Oregon, you see this kind of a riparian area. This is an area that has very small trees. It doesn't have any winter deciduous element at all, because it is a cold water stream. It is a clear water, cold water stream flowing on serpentine. So it is the Illinois River as a tributary to the road. And then the last stop on my riparian journey has been coming to the Grand Canyon, where we have this massive river, a large turbid regulated river that you'd think would have these big cottonwoods and gallery forests, but actually has these asteraceous shrubs. And that's what Emily and I and some of my colleagues have been working on, trying to understand this system. And it's super interesting because it's taking form and it's changing in real time now. So all of these things have, instead of giving me this clear view, I'm an expert on riparian ecology. I've been doing it 25 years. I'm like, my curiosity has just exploded. But my declarative sense of being able to say, this is what a healthy riparian ecosystem looks like, I'm treading lightly on that. So I'm trying to think the next thing. So that's kind of a prism of experience and my personal thing and why I'm here today. But prisms of concept, how do we develop this way of thinking about systems and how they should be, the normative states? And a lot of it's common sense and intuition, right? You think about, this is the way it looks, this is what a healthy system looks like, this is what a degraded system looks like. Selective reading, we never have time to read everything we want, particularly if we find ourselves in a management agency. Most of my management colleagues don't read more than a journal article a month. And the literature itself is selective. There's certain topics that get studied intensively, ones that don't get touched on at all. But I was brought on in the period of the late 80s, early 90s, which was the period of the gurus. And I won't mention any names, but I heard some yesterday, and I'll leave them to you. But there was these people that just had this grand vision for the West of how riparian areas should focus. And I always kind of thought, does this advice serve the guru or does it serve the flock? And I kept my mouth shut at that time. So here's some ideas of prisms of concept. You think about riparian areas, one way to look at them is that they're these continuous systems, non-equilibrium and gradient-based systems that vary continuously in space and time. And the river continuum model is an example of that you think of yourself as a drop of water entering the watershed from the top and coming out at the bottom. Conditions change gradually. Another thing is more of the domain concept. This process domain concept was put out by David Montgomery. And that's the notion that, yes, things change, but they change in these different categorical units. And we can kind of all think of different categories of things. Another one is kind of driven more by the process-dominated group that's maybe patch dynamics and disturbance dynamics that says all the diversity you see out there is driven by these internal processes, whether they be fluvial or disturbance, that can create complexity, but the complexity is consistent across larger spatial domains. And I'll return to these concepts. But these are different filters we look through. And the upshot of all this is, regardless of where you got all these ideas, they're all valid. But the issue I began struggling with is we all have our experience and we all have our literature knowledge and concepts, but rarely are these defined in spatial and temporal context. So we don't know if this idea that we started with here applies over there. It's never explicit. So I said, as we start thinking about riparian management domains, maybe we need to bring in a biogeographic perspective on these kinds of things. I think they should be broadly relevant. We need to look broadly across the system instead of thinking of our one area of experience. I think we need to base our observations on georeferenced and measurable phenomena, because this is the era of GIS and geodatabases. There's no reason not to do that. I think we can refine our ideas with spatially explicit inventory and monitoring data, and whatever we come up with, you have to be able to communicate. They have to be intuitive and easily understood. So the reason I think biogeography is a great framework is, first of all, it's super cool. I mean, that just goes without saying. I mean, it needs no justification. But within the riparian context, I haven't seen it used very much. And I think it tells us some very practical things. Why does a species live where it lives and not somewhere else? And how does that should apply directly to restoration? Past dispersional extinction and speciation events and how those potentially could affect its viability. Vulnerability to future change, and estimated, for this talk, I'll say spatial and temporal boundaries to the way we think about systems and how we apply mental models. So I'm going to give you a 4-slide overview of vegetation biogeography in the West, and this was from my reading and review of the work of Axelrod and a bunch of colleagues up to Thompson. Basically, in the late Mias, the interesting thing is most of our riparian genera in plants have been around for probably 20 to 30 million years. But the structure they took on was largely took place in the last 5 million years. So at 5 million years ago, in the early Pliocene, we had a broad flora across North America that reflected warm waters off the Pacific coast, adequate summer rain, so that we had kind of a homogeneous northern flora and a subtropical flora to the south. But what happened, when the West really started taking shape, was in the middle Pliocene, where you had a massive warming and drying and a massive extinction in the West of a lot of the eastern taxa that you would see in the southern Appalachians. They were here. They were here until 3 million years ago. And then what we see in the mountains is kind of an impoverished, cold-adapted version of that. But what the pullback in the northern species was an expansion for the southern species, and that allowed these southern species to expand into the West. And then during the last 2.5 million years with the Pleistocene fluctuations, what we had was all those southern species that came in had to deal with the cold, the deep freeze. So it never got warm enough that we created habitat for the eastern species to come back, but we really created a lot of complexity within the West. And this is really cool. And so this gave us some things, and when I think about what does this mean for management and ideas, well, you know, the northern species, our Cordilleran flora, all the way down to the Sky Islands of Arizona, have a northern affinity. And you'll see that. And I would imagine some of the wetland species have an eastern affinities as well, because they persisted. The southern species south of the Mogollon Rim and south of the southern rim of the Great Basin have a southern affinity. So there's a lot of people they can talk with down in Mexico. And interestingly enough, California, the Great Basin, the Columbia Plateau, the Colorado Plateau, and the Great Plains all have are endemic to the West. And so they're globally distinct in the world. And that's interesting. And what does this have to do with riparian management? And the interesting thing is, yeah, I mean, riparian areas, we tend to think of them as plants. But the interesting thing is riparian biogeography kind of falls between the cracks. It isn't quite terrestrial ecology or terrestrial biogeography, and it's not aquatic biogeography. It's this bridge between them, and it's an understudied bridge. And we all know from the pivotal role that riparian areas play in any landscape, they must have been huge in the past, and they will be huge in the future. So this is an area that should be studied more. And that's why I'm making the plug for inventory and monitoring programs, which is what I did for the last 13 years with the Park Service, and that was a wonderful period, and that's my acknowledgement to them. So proceeding to getting that job with the Park Service, I did a study of 4 watersheds in Western Oregon, and I was trying to look at these broad-scale patterns in riparian systems. And I guess my question with that study, I had 4 watersheds where I sampled 1 hectare plots, 16 in each basin in 4 basins, and I was looking at woody plant diversity. I'm not going to get into that, but one of the shocking things of that study, when I started looking at the composition, what I found was that fully 95% of the species in that area had change along this climate gradient, versus a little under 50% along a topographic gradient. So that kind of blew my mind, that a riparian area, you'd think the topographic gradient would be massive and the larger gradient would be less, but no, the geography was very important. Another thing I learned from that study as I looked across the species, and I've just got a subset of 12 angiosperm species here, is that yes, you have the classic riparian pattern. This is black cottonwood, Populus trichocarpa. It occurs in kind of mesic climates, but it's not really climatically distinguished in terms of its distributions, but it's very closely fixed to low elevations relative to a stream. It's very fluvially linked. And then at the other extreme, you have these oak species that I saw frequently, but they were in the drier climates and probably are more or less upland species. But you see a whole spectrum across between those 2 extremes, and that is the riparian flora. And so I just wanted to say there's more than one viewpoint in terms of what is a viable riparian species. Another thing that I saw was that as I looked at alpha diversity, which was the species that I saw in a plot, a 4 by 10 meter plot, it had a strong spatial signature and was linked to gross primary productivity and climate. And so space really mattered for that, for what you see on the ground. But what was interesting is beta diversity, which was a measure in this study of the heterogeneity across a floodplain from streamside to hill slope, had a very weak spatial signature. So that's kind of a universal trait of riparian areas, that something about the streams and the heterogeneity in the streams was not spatially fixed. And I came up with this hierarchical model of how species diversity was arrayed, which was these 3 things from climate down through disturbance and competition across broad spatial scales in Oregon. And I should say one last parting shot. I just charted up some data last week from my time with the Park Service, and this was kind of interesting on this front, and this was inventory and monitoring data. And we used a vegetation protocol to measure things, and this was exactly the same protocol. It was the first time I looked at the data from all 4 parks in an ordination space. And once again, they're completely different. They don't overlap at all for these 4 parks in Northern California, Southern Oregon. So the spatial signature is non-trivial, is the bottom line. So this brings me to the work that Nate Huffsney and colleagues did, which I really thought was interesting and got us on some really good conversations, which they were looking across the PIBO data set in the northern, if I understand it right, the Columbia Basin and the upper Missouri Basin, which is a large gradient across the northern part of the country. And they came up with some similar things. They said there's a regional species pool, and then it goes through serious filters where the flora of a site is limited by different processes at different scales. And I thought this is a really neat way to do it, and I thought they took it into much more resolution than I did and had some good discussions of some of the interactions here. They found, as I did, that the bioclimatic space of these riparian communities was very important, and they were distinctive. But they also found that as you get to the smaller scales and you start to look at the reachlet scale, that these communities do partition themselves out by geomorphic features. So these things are not mutually exclusive. They're just kind of scale dependent, these different controls on riparian plants. So I guess the upshot of all of this and some of the work that I've done is, and that Nate's done and colleagues and other people, I'm not the only one, is that riparian communities are not homogeneous across large spatial scales. I mean, that's pretty self-evident. I think we can start thinking about these hierarchically in terms of different controls on conditions. And I think we should gather information on a lot of species so we see different kinds of patterns. So to return to some of these conceptual models, just with one slide, I won't torture you with this. First of all, Tobler's first law of geography is that things tend to be similar, but things that are closer are more similar. So basically, your prospects of being wrong increase with distance. That's just a given. So if you have an idea here and you export it too far, you're probably wrong. And that's probably a good cautionary rule, but it's not very illuminating beyond that. Here's what I think in terms of my exploration for this talk is that, in riparian systems, they're hierarchically ordered domains with delimited and predictable structure in time and space, but they contain dynamic fluvial systems that are governed by universal laws. So basically, we can bring both of these kind of levels of thinking into it. So my first pass at this based on the work of Axelrod, and this is just really, really shooting in the dark almost here, shooting in the dim light, is that these would be the riparian management domains for the West based on plant biogeography. There's not very many. There's northern species which have certain attributes, southern groups that have other attributes, and then endemic domains that have certain attributes. I'd like to explore these ideas too, so I'm just cutting my teeth on this. And if I haven't interested you with this, I'm going to try to make a case of why this should be relevant to riparian management and restoration, which is that riparian systems have spatially structured and non-spatial, I would just say universal properties. And I would say, quickly said, a lot of the patterns that we see in the western US, which is a very strongly spatial patterned landscape, as I put out in my first couple slides. The climate topography, hydrology, biodiversity patterns all are extremely important. Other sorts of practical things like restoration constraints, what are the things that are likely to get in your way when you try to do restoration? What's the role of large wood, and things like that. What's the role of land use? What's the buffering capacity of the water? The role of soil salinity? All these things are regionally vary in importance. But on the other hand, a lot of the processes that we're talking about, and we come to meetings like this to share, are universal. So we certainly can share concepts freely in that domain. At least that's my thinking. So the take-home messages I have from this presentation this morning are that, Riverscapes and Mindscapes, kind of have diverse origins, but if we bring them together through getting the way we think about and understand geography and our own origins of our own thoughts, should be helpful. I think inventory and monitoring and biogeography will be great tools towards that quest. And I also think that this pursuit of riparian management domains, understanding how the West is spatially structured at a first pass, will help us get better at what we do. So thank you very much.
We have plenty of time for questions.
Are there any?
Bueller?
Oh, sure.
So in all of your literature research and evaluation, we talk a lot about riparian areas and biological processes. How much of it is it from the human species side of things, and the interaction between humans and riparian areas versus, we know that people love to recreate on riparian areas, there's soil impact, there's vegetation loss, trampling. How much have we looked at the human side of interaction with riparian areas versus biological?
I think the question is how much have we looked, and I don't know who we is, you mean the riparian community? All of us? How much have we considered the human dimension as opposed to the biological dimension of riparian areas?
Correct.
That's a really good question. I don't know that I can answer that. I think in the Grand Canyon where I work now, the human dimension figures pretty prominently. And certainly with our talks about livestock grazing and other sorts of things yesterday, we were considering those things.
But even traditional uses, Native Americans, use plant gathering, tick species, transplanted species. There's always been a human component of it, but I just want to know in your literature review, how much have you seen?
I haven't seen that much, and I haven't seen as much of that human component, and I would say I'm certainly no expert on that. I think it's fascinating because they're special. I mean, we know they're special, riparian areas, especially in the West. And I'm sure the native people knew that too.
Any other questions?
I have a question.
Yeah.
In your research in Oregon looking at plant species, have you looked at other forms of diversity, so like functional diversity or phylogenetic diversity, in the comparisons across either the state or across the West?
No. Sorry, the question was, in my studies in Oregon, had I looked at multiple kinds of diversity, phylogenetic diversity, functional diversity, and other sorts of diversity? And the answer was no. I was kind of pretty simple, pretty Neanderthal, you know, species richness of woody plants, which I admit is, you know, tip of the iceberg.
We don't have any other questions? Let's thank Daniel.